Amanda Graff. I'm a product line manager in our data center business, specifically in our network platforms group. So we're focused on network and telecom customers. Specifically, I focus on our Xeon product line, and so we'll get into that. But wanted to talk a little bit about how Intel is trying to position itself in this market. I'm a marketing guy, so it's a little bit different audience than I normally present to. But so, you know, as we look at the network, we know that there's a different set of requirements that exists at each of these nodes, right? There's different core counts that are required, different thermal specs, different power consumption requirements, all these different kinds of things. And so it's not a one-size-fits-all in terms of the hardware. So Intel is really making sure that we've got a wide variety of investments that can play in all these things. Shane was here earlier talking about the IoT edge, right? The industrial part of the fourth industrial revolution. And the business that I'm in really covers everything from the access and network edge all the way back to really the telecom cloud and data centers. You know, the edge workloads require different type of they have different requirements than the requirements that we see back in the data center or in a central office or something. So one of the things that we've done is made sure again that our CPU roadmap is something that addresses all parts of the network. So if you look down on the bottom left, that's where we've got our lowest performance and lowest power CPUs. This is our Intel Atom processors. It's a SoC. We're typically seeing these Atom processors going into base stations, UCPE type workloads, you know, things that are going to just be at the local branch office. Moving out from there, we've got our Intel Core processors. This is traditionally it's kind of just drafted off of our client business. So this is using those CPUs, but they've been modified for more telecom and networking workloads. So a lot of these are supporting the encoding, decoding, and transcoding. You know, a lot of our appliance-based business is still running on this Intel Core processors. Then moving out from there is when you actually get into our Xeon family, and the first Xeon CPUs that you see on there are Xeon D. The D stands for density efficient. So this is a system on a chip. It's using our Xeon families, however, but for certain in certain use cases, we know that customers, just based on the form factors, whatever it may be, an SoC is actually what they're looking for. They don't necessarily need all the cores that you would get in a standard in our Xeon Scalable family, and so the Xeon D line is a nice place for them. Then where I focus my time is on the Xeon Scalable processors. This is our highest performance, highest power CPUs, you know, up to 600 gigabits per second on packet processing on our dual socket platforms. These have lowest latency, support a variety of IOs. And so what we see here is that, again, we've got a CPU roadmap that is addressing everything from that kind of network access edge all the way back to the data center. And then one of the things that we're trying to do, though, is make sure that we are removing bottlenecks wherever they exist in the network. And so that's where we've invested in some of these other technologies, AI technologies, FPGAs, NICs, that sort of thing. Okay, so just recently in April, Intel and our data center group had a big launch event. It was the launch of our second generation. It was a data center launch where we released a variety of different products in the data center. I would say the major focus was actually on our second generation Intel Xeon Scalable processor. So this is formerly codenamed Cascade Lake. The first generation was codenamed Skylake. The second generation is Cascade Lake. So this is a big launch. There's a couple of things that we did with this launch. There's a couple of new things that we've added and a couple that we would consider more revolutionary, and then there's some evolutionary things. So on the revolutionary side, we've launched our Intel Optane Data Center Persistent Memory. So this is a new memory tier. It's not DRAM, but it has DRAM-like speeds with pricing that's more similar to NAND. So it's kind of a nice, I don't want to say hybrid, but it fits in the memory hierarchy. There's certain times where DRAM is not the right technology for people to be using. It's maybe too expensive. They can't afford to put a lot of it on a platform. These Intel Optane DIMMs are the right, in certain use cases are going to be the right feature for them. So non-volatile 3D crosspoint DIMMs are some of the revolutionary things. The next thing is deep learning and AI workload instruction sets that were not available on the prior generation Skylake, but they are available on Cascade Lake. Then in terms of the better than ever fundamentals, right? So every generation we want to make sure that we continue to add performance. And what we've done here is per core performance compared to the prior generation is up 6%. But then in terms of total performance, we're seeing improvements of up to 40%. That's because we're adding additional cores, and then these cores are better performing cores than the prior generation. Where I'm going to focus the rest of my time today is on these new network optimized SKUs that we've released that are targeted for network workloads, and they provide additional performance benefits relative to the prior generation. Cascade Lake, this second generation product, second generation Intel Xeon Scalable processors, they are pin-to-pin compatible with the prior generation. So for OEMs and our customers who have invested a lot of money validating those platforms, the prior generation, they're able to use that existing platform, that board, and it's drop-in compatible, so they don't have to make significant investments. Yeah. Yeah, it's just different parts that have different configurations, right? Some of them are going to have higher core counts, different frequencies. Yeah, so a customer, is going to have. Yep, it's an ordering thing. Yep, just a way of differentiating parts that have different features, different technologies. Again, the second generation, they're able to customers are able to maximize the investment that they've made on the prior generation because it is on the same platform. So now I want to get into a little bit, I think this is generally a very technical crowd, so the pricing may not be the most interesting thing, but what I wanted to highlight here was just that we're seeing significant performance improvements. The SKUs, so again, SKU just meaning on the left, you see, for example, we've got, let's start up there, we've got like the 5118, right? So that was a 12-core part, 105 watts was the TDP, and 2.3 gigahertz. So the next generation, we've added a network optimized SKU, so we're adding 4 additional cores, going up to 16 cores. It's the same number of bins and frequency, and then for 110 watts. So you're getting 4 additional cores at basically the same thermal envelope. Then if we go up to something like, let's look at the 6130. That's our Skylake family. So that was a 16-core part, 2.1 gigahertz, but then with the network optimized SKU, you're getting 4 additional cores, 2 incremental bins, but still at the same thermals, right? So for certain customers that simply adding more cores isn't the solution for all customers. In some cases, that may work, right? Just adding more cores, they don't care about what's going on with the thermals. They say, hey, we've got a big data center that's maybe not the most critical thing for us. We just want the best performance possible. But in the case of a lot of these telecom and network customers, they've got a very fixed thermal envelope, and so these network optimized SKUs allow them to take advantage of some of those benefits. One thing we've also seen, and I don't think it's listed on here, but we've also seen that there is a shift and a demand for single socket CPUs. In the past, most of our business has been on the 2-socket part of the 2-socket SKUs, but we are seeing more and more demand for these 1-socket parts. So we've added that to the roadmap. That allows customers, With the one socket configuration, they're able to, it may be better for certain use cases like on an edge deployment. So some customers, they simply say, hey, we're putting this into a rack that doesn't have space for a 2-socket configuration. We want to make sure that we've, can still take advantage of your newest generation, but we don't have space for a 2-socket CPU or 2-socket platform, and so we offer a single socket platform for them. So in general, though, you see kind of in that middle range there with these network optimized SKUs, you're seeing upwards of, in some cases, 40% performance improvement over the prior generation. So continuing to make sure that our customers, generation to generation, are getting more performance. One of the unique things that you'll see in some of the, especially in the non-network optimized SKUs, is that the pricing from one generation to the next stays flat. So what we're trying to do there is make sure that customers can continue to get more performance for the same price. Or conversely, although we don't see this very often, or they could get the same amount of performance for less. Although we do typically see that customers are more interested in more performance. Every generation they're demanding more performance, more cores, and so we do typically see that they either stay at typically about the same level or they're moving up in terms of the level of performance. So I'll actually skip this slide. We can maybe come back to that one if we want to, but I wanted to talk about the features that we've added on our network optimized SKUs. So there's 2 technologies that we're really trying to take advantage of on these network optimized SKUs. The first one is an incremental 10% performance without any code changes on NFV workloads. So that's on. So again, we've got 3 network optimized SKUs, and on 2 of them, we are offering 2 additional bins of frequency. So rather than running at 2.1 gigahertz, they can run it at 2.3 gigahertz. But again, it's going to have the same thermal envelope. So you're basically getting just an additional 10% performance, and it's the exact same CPU and everything. It's just a higher performing dies that we've selected from our silicon. And so we're able to offer more performance. There is a price premium, but it's not commensurate with the performance increase. Then, so in that case, again, we're seeing that you can simply, rather than running all of your cores at 2.1 gigahertz, all of your cores can now run at 2.3 gigahertz. The second thing that we've enabled on these network optimized SKUs, and this is the one that's a bit more interesting in my mind, is dynamic configuration of the CPU frequency. So if you think of a CPU having a fixed total frequency, you're allowed to play with that a little bit, where certain cores can run at a certain frequency while other cores are running at a lower frequency. So this enables the density of your VMs to increase, because certain workloads are going to need those higher performing cores, and certain workloads are going to maybe don't need that much performance. So this is something that enables them to get additional benefit above and beyond just the 2 extra bins of frequency that we're offering. So the idea there, actually, let me take a step back. So I mentioned that there's 3 network optimized SKUs, right? 2 of them are taking advantage of additional bins of frequency at the same thermals, and then our 5218N SKU is taking advantage of it's the same frequency but with a lower thermal envelope than the prior generation. So let me show you what we've done here. So if you look at the chart on the right, we're basically showing performance from our first generation Intel Xeon Scalable processors, codenamed Skylake. So we look at a 6130, which is the black. Then you look at our standard 6230 option. So that's just a SKU that doesn't take advantage of the network optimized SKUs. And then that same SKU, but the one that it's offering the 2 incremental bins of performance. So you can see this is the performance of various different workloads, right? So VPP on OVS DPDK, virtual firewalls, just across the board, virtual EPC, where we see that the extra 2 bins are giving customers a lot of performance. This is something that we're hearing from a lot of our customers that, hey, it's kind of a no-brainer. It's just extra performance, and it's enabled right off the bat, so that works well for them. Typically, we're seeing about 8 to 9% performance, or I'm sorry, 8 to 9% pricing increase compared to the, it's a premium of 8 to 9% relative to the standard Skew, but the performance that they're getting typically is going to outweigh, and obviously it's going to depend workload to workload, right? Certain workloads are able to take advantage of this more than others. Okay, now let me get into a little bit more of the dynamic configuration that we were talking about. So this is something where, depending on the Skew, right? So on the left, we've got the 3 network optimized Skews. So on the 6252N, what we've done there is it's a 24-core part. Standard, it's going to run at 2.3 gigahertz and 150 watts. But with this technology, it's called Speed Select Technology Base Frequency, SST-BF. So you may see that in some marketing documents or some of the technical work, especially if you work with like an ISV or an OSV. But so this Skew, again, that's the standard if you're just taking advantage of the additional frequency. But what the SST-BF does is allow you to run 8 cores at 2.8 gigahertz and 16 cores at 2.1 gigahertz. So it's a zero-sum game, right? You're taking performance away from certain cores and giving that performance to other cores. But what that does is allows you to identify mission-critical workloads and workloads that are maybe a little bit lower priority. So typically we're seeing data plane type workloads are going to, customers want to use the incremental cores, the incremental frequency for those data plane workloads, and some of the control plane workloads, they say, that's not as critical it's not a mission critical workload, and so I'm okay having a little bit less performance on those roles, on those cores. So, you might ask, well, why would everybody not use this, right? It sounds great. Well, there's certain times where there's certain workloads where this makes sense, right? If you've got workloads that need that extra performance, it absolutely makes sense. But if you've got workloads where all cores need to be running, or you're using all of the cores on a given CPU for your workload, it might not make sense, right? So you have to we're encouraging customers to use the benchmarking that we've done and actually go and figure out which. We're sharing with them, hey, these are the workloads that are really going to be able to benefit from this. So some of the ones that we've identified so far, again, OVS, DPDK, L3 forwarding, and VC cap. So that's what this chart here is showing, is that relative to just using, so again, if you're just using the additional P1 frequency, the additional 2 bins, on OVS, you're going to see an 11% performance improvement when you utilize the SST-BF. DPDK-L3 forwarding, you're going to see a 12% improvement, and then VC cap, you get an additional 4%. And that's something that comes, if you buy the N Skew, it comes with that feature. It doesn't cost any additional money to actually utilize it. So, I'm coming from a hardware perspective, and it's easy for us to just say, hey, we've got this new hardware, have at it, but we realize that means that there's a lot of downstream implications in order for customers to actually be able to take advantage of these technologies. So we're working with the ISVs, the big operating system vendors, to make sure that users can configure this on their own, because we want to make sure that we're not just putting a technology out there that isn't consumable. And so we're having to make sure that we're working with people all throughout the value chain so that end customers are actually able to take advantage of it. Do you have a question here? So it's on boot only right now. So that's a little bit of a downside, right? So customers are, and so that's one of the things that we wanted to make sure that we got this technology out there took the feedback and said, okay, that's not ideal, right? If you're having to reboot to get this technology going, to configure it, that's downtime that a lot of customers aren't willing to deal with. And so that's absolutely one of the things that we're looking at for next generation, is making sure that this is something that you can do live on the go without having to reboot. Okay, so again, this is, I mean, we think this is a pretty neat technology. It continues to make sure that customers have the flexibility that they need for the workloads that they're running, and it gives them the performance that they're looking for generation on generation, to make sure that, you know, that they're staying competitive, that they're able to offer a lot of these new services at the edge, and make sure that their customers are, you know, that the OEMs that we're selling to, that their customers actually get to take advantage of these benefits and offer those new services. All right, so in summary, the key takeaway from this is that generation to generation, this Cascade Lake, right, the second generation Xeon scalable processor, offers significant performance benefits versus the prior generation. You know, we continue to invest in our Xeon product line, and we'll continue to see those types of improvements going forward. Then these new network optimized SKUs with the key technologies, again, the higher P1 frequency, so the additional 2 bins of frequency, and then the Intel Speed Select technology base frequency. That's the one where you get to configure it and have certain cores running at a higher frequency and other cores running at a lower frequency. That allows for a continued improved energy efficiency and performance for our network workloads. So we continue to hear customers wanting to have flexibility in what they're doing, and so this is the way that we've provided that to them in Cascade Lake. Any questions? We got here in the front. Yeah. Well, so if you go back, I mean, right, we looked at the, there's absolute performance improvements, and then even on a per dollar basis. So if we go back here, right, so here we're talking about, this is where pricing remains constant, and yet you're getting an additional 14%. We could have, absolutely. Yeah, no. Yeah, absolutely, and that's one of the things that we look at is we try and figure out, right, what's that trade-off of, we could, right, sometimes there's the perception that, are we giving away performance, right, we're just giving it away, but we realize that customers continue to demand. Yeah, no, you're absolutely right, and so and that's one of the things, though, that we're regularly evaluating our pricing. This is where we're at today. Yeah. So, but again, key takeaway is that generation to generation, there's absolute performance benefits. Yep. Any other questions? All right. Yeah.
And is there a return on that for users and for the company, and how much money was spent on that particular project?
Yeah.
Whether you add the corporate overhead.
Yeah.
There's a better way to look at it. I didn't see in the project.
Yeah, so that's one of the things, each customer that we work with is going to have their own definition of a TCO model, right? Total cost of ownership. And that's one of the things that we try and make sure is that they do see the return on their investment. So that's why we try and utilize the same platform, right? So we're using the same platform with just this generation. So they don't have to do all the same validation work that they did on the first generation. That's the way for us to help them lower their total cost of ownership. But then you also have to take into account, there's additional performance, generation. Absolutely. Yeah. That's something we're absolutely aware of. I know there's a lot of big news coming out of Computex this weekend and everything, and so we're absolutely, paying attention to competition, and we can't speculate on too much. We don't really comment on where they're at because we haven't, things haven't launched. Right. Well, and so, yeah, we make sure that when our customers are asking for continued improvement, generation to generation, here's how we're delivering it. Yep.
Just add to the answer from the Nathan for the SSTBF. That's initially when you just enable very first time, that requires BIOS setup, which requires the reboot. But once you enable that mode from the BIOS, and then you once enable mode, basically you just running the daemon, it's the agent program, you can toggle on and off the STBF, yeah, without rebooting. It's not gonna be microsecond, but it'll be like few seconds, yeah, few seconds, yeah.
Okay. That's all. Thank you.